Hi, I'm David Bolton of Go Parallel. Today I'm going to show you an attempt to speed up a game that I wrote a few years back. The game's Asteroids, and it's been programmed in C. I've recompiled it using Visual Studio 2013 Community Edition, and it uses the open source libstl library. So let's have a look at the game running. So if I press the F key, you can see in the caption bar how many frames per second. And if I press T, it'll start adding a few random sized asteroids. As they hit each other, or if I shoot them, they explode, and you can see the animation frame. As the number of asteroids on the screen decreases, the frame rate speeds up. So if I get rid of the last one or two here, you'll notice the collision detection isn't very perfect. It needs improved. The game runs on an Intel i7-950, which has 4 cores, and with hyperthreading that makes 8 cores available. As it's programmed in C, I've chosen to go down the OpenMP route to try and speed it up. The alternative is Intel thread building blocks, but that's only available for C++ and Fortran. I want to try and improve the game by speeding up the sections of code that calculate positions of bullets, and this also cycles through the animation of the explosions. I can't parallelize SDL functions as they're not thread safe. I did try it, and though it runs okay for a few seconds, it inevitably crashes with an exception, and it's always in the call to the SDL blick function. So even trying it inside an OMP critical section, it would not work. It limits what I can actually parallelize. I recorded the number of frames per second in release mode for the game in both parallelized mode and non-parallelized mode. In both cases, when there are no asteroids on screen and when there are 60. By pressing a key here, I can add lots and lots of asteroids and can get it up to around 60. So I spent a fair bit of time doing this and just checking the frame rates. The frame rates you see here are a bit lower than what I got before because I've got other software, the video software running in the background. And the figures I got for the non-parallelized mode were 410 frames per second when there's no asteroids on the screen and 360 when there's 60 asteroids. For the parallelized version, it's actually slightly worse. The figures are 400 frames per second with no asteroids and 350 when I've got 60 asteroids on the screen. Now, it's only 10 frames per second worse in the parallelized mode, but even so, it makes you think, why is it slower rather than faster? So I decided to run the program through Intel Advisor XE to try and figure out where I was spending most of the time. This is part of the Intel Parallel Studio, and it's very useful when you're trying to optimize threading code. So start off with a survey. So this is now going to run the program in survey collection mode, so we'll hit it a few times just to give it a good try out. Rotate. You can see things are running even slower now, but they're not too bad. Alright, that should be long enough. I'll stop the program, and now the Advisor software will finish off, and in a few seconds we should see where the program is spending most of its time. This is a bit slow, but again, it's because of the running of the video software in the background. And there you have it. You can see that most of the time is spent in the game loop. Here it's 95.6%, and of that, 66.5% is spent doing blitting, and 22.4% is doing a flip, with the rest of the time split between draw explosions, draw asteroids, SDL pole event, draw player, etc. Now those functions are ones which call SDL, so they're not really good for being parallelized. In fact, the rest of the code that I have parallelized seems to be using very, very little time, and so little time, in fact, that it's not showing up here. And that's probably the reason why it ran slower. I'm guessing the overhead of doing the OMP code is what made it slow, because there were no actual speed gains. Well, I think this experiment can best be described as a failure. I wanted to speed it up, but most of this game is spent drawing or flipping, and it can't be speeded up because the SDL code can't be parallelized. But it's not all bad news. If we go back to the 60 frames per second version, it means that each frame takes 16.67 milliseconds. And we know that when the throttling is removed, that a while statement that causes it to spend time just doing nothing, it can run at 400 frames per second. So that means that the drawing time, total time for doing all the drawing and the blitting, takes about 2.5 milliseconds. So when you've got it running at 60 frames per second, Of those 16.67 milliseconds, only 2.5 are used for the drawing. That leaves over 14 milliseconds to do other things such as AI code, stuff that runs in the background. And the good news is that kind of code can be parallelized because it's not using the SDL, it's pure code. So if you're doing a game, bear that in mind. Thank you for watching. I'm David Bolton, Go Parallel.